Picking up where we left off yesterday, we have learned product rule. Derivative of one, keep the other, plus, and then you flip-flop this situation. Quotient rule is what we were working on. F of x equals natural log of x over x minus 2. In order to do the derivative, what do I start with? Derivative of the numerator times the denominator. Then what? Quotient rule says minus. And now it's derivative of the denominator. Derivative of x minus 2 is 1 times the numerator, which is ln x. All over x minus 2, quantity squared. Now, let's see, what way do I want to do this? If we go ahead and distribute on top, I think I'll do that. 1 over x times x is going to be 1 minus 1 over x times 2 is going to be 2 over x minus 1 times natural log of x is minus natural log of x, over x minus 2 quantity squared. How do we clean this up so it's more of an approved final answer?
You can subtract the natural log of x, right? No.
Well, my problem is that there's a fraction within the fraction.
Multiply by x.
So in order to get rid of this denominator, you multiply by x. If I multiply the numerator by x, I have to multiply the denominator by x. So we'll multiply an entire fraction by x over x. And now the nice part will be we won't have fractions within fractions. So multiplying every term on top by x gives me
X ln
over
x times the quantity x minus 2 squared.
Okay, so x minus 2 minus x ln x over x times x minus 2 squared. That's what I have as final answer in my notes.
Nice.
Okay, D. Y is sine x over 1 plus cosine x. Quotient rule. Derivative of the top. Derivative of sine x is cosine x times the denominator. Then minus derivative of the denominator.
Negative sine x.
Okay, derivative of 1 is 0. Derivative of cosine x is minus sine x times the numerator, which is sine x, all over the denominator squared. 1 plus cosine x quantity squared. Okay, let's do some cleanup. On top, I would often encourage you to multiply things out. On bottom, I would not. Okay, just generally, how things tend to be. Take the cosine x and distribute. So if I distribute the cosine x, I'm going to have cosine times 1 is cosine, plus cosine times cosine is cosine squared. Then what? Minus times negative is going to make it plus, sine times sine, plus sine squared x. All over, I'm just going to leave it as 1 plus cosine x quantity squared. At least I assume that's what I left it as.
It seems so weird to me that can be a
This could be a final answer, but we could also go another step.
You could
What?
do at the bottom.
That equals 1.
What equals 1?
Cosine squared x plus
It does?
Yeah.
It does.
It's your Pythagorean identities.
Okay. I wasn't sure. Because I know who's the other one on the other one.
Okay. There was one yesterday. Doug tried to. He tried to say it was 1, but there was a minus sign in there. I don't remember which way it was subtracting.
It was 2 cosine squared x minus 2 sine squared x.
Okay. So Pythagorean identity says sine squared x plus cosine squared x is equal to the value of 1. So with that in mind, I can clean this up and say cosine x plus 1 over 1 plus cosine x quantity squared. And this is why the Pythagorean identity was good here, because you can actually do a little bit more canceling. The top is cosine x plus 1. The bottom is 1 plus cosine x times 1 plus cosine x. So the top has one of them, the bottom has 2 of them. So if you cancel one of them out, we're at 1 over 1 plus cosine x. Not that the others aren't equivalent, but these are things you got to be able to look for too. Okay?
So on the AP test, which one would they probably prefer?
Well, if you're, honestly, you'd see something like this more in multiple choice, possibly, I would think. Okay, so in multiple choice, it's, could they maybe simplify it down to something like this? Yeah. Okay. Okay, bottom of this page. You know, I tried to stress yesterday, the product rule doesn't matter. Derivative of one, keep the other, and then flip the situation because you're adding, right? Subtraction here, okay? Reminder that subtraction is not commutative. It's not, okay, do one, then the other. It doesn't really matter. It matters. So you have to be careful with the quotient rule. Quotient rule is not to be interpreted as the derivative of a quotient of two functions, f and g, is the quotient of the derivatives of f and g. So that's just saying that you can't just say, oh, it's two functions, I'm going to do derivative of each. Okay, that is a no-go there.
Because that would be too easy.
Yeah, that'd be too easy, exactly. Same thing, we had this same statement somewhere else about the product yesterday. It's not just derivative times derivative. Okay. She has in here another fun mnemonic. Basically, the lows are changed to hoes, and so you've got Hody Hi minus Heidi Ho over Ho Ho. So.
Santa Claus.
Where's Santa Anita?
Or it's me.
Okay, continuing along. Find an equation of the tangent line to the graph of f at 0, 1 for f of x equals cosine over 1 minus sine x. An equation of the tangent line. What do we need to write an equation of a tangent line? A slope and a point, yes? Okay, so we have our point, we have our xy. What we don't have is our slope. What do we have to do to get to our slope? We have to do the derivative. So, f prime of x, derivative of cosine x over 1 minus sine x. This is the opposite of what we just did, isn't it?
Yeah.
Okay, just making sure. I was like, mate, can I steal my answer? Okay, derivative of cosine x is negative sine x times the denominator, 1 minus sine x, minus, because it's a quotient, derivative of 1 minus sine x, so derivative of 1 is gone. Derivative of sine is cosine. Since this is a minus sign, we're going to say minus cosine times the numerator, which is cosine x, all over 1 minus sine x quantity squared. Should work out similar to the last one if I had to guess, right? So we're going to distribute minus sine x plus sine squared x plus cosine squared x all over 1 minus sine x quantity squared. What do you notice? Sine squared x plus cosine squared x is going to be a 1. So we end up with negative sine x plus 1 over 1 minus sine x quantity squared.
That's another.
Yeah. 1 over 1 minus sine x.
It's not another identity, but it's just the fact that negative sine x plus 1 is 1 minus sine x. There's a 1 minus sine x on top, or on bottom, so we can write this as 1 over 1 minus sine x, yes? Okay, that's our derivative. What am I supposed to be finding?
So,
I need my slope to get to my equation.
Oh.
I don't have slope, I just have my derivative.
That's slope of the tangent line.
I have the derivative, which is the slope of the tangent line, so plug what in? Yes. Or you plug in xy technically. In this case, all we need is the x. So 1 over 1 minus sine of 0. I go straight to the graph in my brain because I can easily visualize the graph of sine.
0, 0.
Yeah, because the graph of sine starts at 0, 0, doesn't it? Before it goes up, down, up, down. So this is going to be 1 over 1 minus 0, which is 1. So what is that 1 I just found? That is your slope. So we've got a slope. We've got a point. Find an equation of the tangent line, yes? So y equals 1 times x minus 0 plus 1. What does that really clean up to be? Y equals x plus 1 once it's all done and over with? Okay. Moving along. The next part of this page talks about using the quotient rule to develop rules for the 4 remaining trig functions. Technically, I mentioned one of these the other day. We should only have 3 remaining. Yeah, we mentioned tangent because it was in the notes that I needed to fill it in the other day, wasn't it? Because it talked about to memorize it.
Secant squared.
Yeah. So, now, what this comes down to. Ultimately, the big plan needs to be you just need to have the 6 trig functions memorized. Okay, that's just all there is to it. You need to know those derivatives. Now, with that all being said and done, could you technically figure it out doing this type of trick? Yes, you can. Okay, and that's what we're going to look at here. So, quotient rule. Well, in order to employ the quotient rule, we need a quotient. What do you know about cosecant? Cosecant is the reciprocal of sine. So this is equivalent to 1 over sine of theta.
1 over cosine theta.
Nope. Sine. Okay.
No.
Now,
Well, I was just thinking.
we're ready to find the derivative. Okay. We're going to find the derivative. I find it interesting that they do cosecant first. I would do like this one last, but we're going to find the derivative. So, quotient rule. Derivative of the numerator. What's derivative of 1? 0 times the denominator minus. Now it's derivative of the denominator, so derivative of sine is cosine times the numerator of 1 all over sine squared theta. Okay, what's my numerator clean up to be?
Oh shoot! Why did they change the theta and not just keep it at freaking x?
Negative cosine theta over sine squared theta. Sorry. All I can do is laugh there. Now, this is not what I have memorized as the derivative of cosecant. Okay, this is not what most people would expect you to have memorized as the derivative of cosecant. I'm looking for this in another form. Okay, it is going to be a negative.
Negative sine.
Okay, so I'm hearing cotangent. Why are we saying cotangent?
Because you can.
Oh,
Okay, so cotangent
Squared.
is cosine theta over sine theta, correct?
Mm-hmm.
But what else do we still have in here?
Another sign.
We have another sign. So I just rewrote this equivalency, yes? It's still negative. Cosine over sine squared is cosine over sine times 1 over sine. Negative. Cosine over sine, you already told me, is cotangent. What's 1 over sine? Cosecant.
So cosecant is just, it has cosecant in its.
Yes. So what we can say here, dd theta, the derivative of cosecant, theta is equal to negative, I'm trying to think, do I normally say cotangent, cosecant? I think I normally say cosecant, cotangent is what I think you normally see. I'm not saying it matters. But the derivative of cosecant is negative cosecant cotangent. Throw in some thetas because I should be mentioning the thetas. So yes, the derivative of cosecant has cosecant in it. Okay? Got it?
Yeah.
Okay, moving along. What are we doing next? Secant? Okay. So secant, guess what secant's going to have in it?
1 over sine.
It's going to have a secant in its answer.
There's going to be a tangent.
There is going to be a tangent.
So is it tangent cosecant or tangent secant?
It is.
wow.
I'm so good at this, guys.
Way to ruin the game.
Seriously.
Fine by me.
Okay.
Shame.
There is definitely a connection here, and that's what Sophie was kind of figuring out. Is there is a connection. Now, okay, so secant is the reciprocal of cosine. So secant is 1 over cosine. If we employ the same rule as earlier, I'm not going too quick on these, am I?
No.
Okay. The derivative of the numerator, 0, times the denominator, minus derivative of the denominator. Derivative of cosine theta is negative sine theta times the numerator of 1. Whoopsie. Sorry, my line went too long. All over cosine squared theta. Numerator cleans up to be sine theta over cosine squared theta. If you break this up, so it's in a form other than sine over cosine squared, you probably see where this is going, and that there is a sine over cosine you can see, and then an extra cosine on bottom, right? And so when we change those to actual just trig functions, sine over cosine is tangent of theta. 1 over cosine theta is secant theta. And so the derivative of secant theta is equal to secant theta tangent theta.
Which Let's do the next one because that's just secant squared theta.
We can skip it.
Yeah, there it is.
What if I want to know how we get there? Did I have it?
Then we'll use D. We'll
Okay.
use D to figure that out. Okay, now, so derivative of secant with secant tangent. We learned the other day that the derivative of tangent theta is
Secant squared theta.
secant squared theta. Now, we're going to work this last one out so you can see the hows, but I'm entertaining guesses. What's the derivative of cotangent theta?
Cosecant squared theta.
Negative.
Oh, shoot.
Wow.
Dang it, Sophie. Good job, Emma. Thank you.
You're seeing the connections though, aren't you?
Yeah.
And that's one of the things I'll say is if you kind of memorize half of them, you kind of got the other half then. You just kind of know they go with opposites there. I was waiting. I was like, okay, come on. Someone's got to see that there was a negative relation earlier. Okay. Now, with this one, let's work through cotangent, okay? What do you know about cotangent as a fraction? Other than 1 over tangent.
Cosine over sine.
It's cosine over sine. You see that? Okay, so we're going to use the fact that it is cosine theta over sine theta. So, the derivative of the numerator, derivative of cosine is negative sine, times the denominator, so times sine, minus derivative of the denominator. Derivative of sine is cosine times the numerator, which was cosine, all over denominator squared, so sine squared. Are you with me?
I think so.
Numerator. Negative sine squared theta minus cosine squared theta all over sine squared theta.
Numerator for negative. Basically play with the every
Okay, so the connection to make here, both terms in my numerator are negatives. You can think about factoring out a -1. And if you factor out -1, then I have sine squared theta plus cosine squared theta all over sine squared theta. What do you know about sine squared theta plus cosine squared theta?
1.
That's your pi of 1. And so now I end up with -1 over sine squared theta. What's the reciprocal of sine? Cosecant, so this is going to be negative cosecant squared theta. We actually did the more difficult one there because we had the negative to mess with.
It's okay.
Can you kind of guess how C would work out then?
I already have it.
Okay. And this is where, feel free to go ahead and work back.
Oh, shoot, we just left
You
one.
guys-
No one asked.
Oh, I just flipped 2 pages. I was like, wait a minute, how do we only have 1 page left to go? Ooh. Okay. And I was like, why? We only have 1 page left to go. We're not even to lunchtime. What?
I thought we still had 1 page to go.
No, we have
Oh,
2
that's
pages.
cool.
Black.
Yeah.
Okay.
Yep.
Wait a minute.
Yeah.
Whew, there we go. Okay. You got to memorize?
Sine.
Hold on.
Cosine. Negative sine.
Anyways.
Oh, all right.
Alright,
Mario.
just keep going if we're gonna upset something.
Yep, you put my down.
No, I haven't, because I'm yelling at you.
I wrote them in. I didn't say anything.
My data.
Forgot about that trick. Okay. Derivative of sine is cosine. Derivative of cosine is
Negative.
negative sine. Derivative of tangent, secant squared. Derivative of cosecant, negative cosecant cotangent. Derivative of secant is secant tangent. Derivative of cotangent is negative cosecant squared. Throw a bunch of thetas in there. Now, this is a trick that I'm sure it was new to me last year. I don't even remember it, but there's a connection to be made if you want it. Cosine, cosecant, and cotangent all begin with the letter C. And all of their answers are negative. I don't know if that's a good trick or a bad trick, but if you're trying to remember where your negatives go, I don't know. I have that written in my I have it written in my notes. C is negative. I have it written like this, and I'm like, what did I mean by that? And then I realized that I have cosine, cosecant, and cotangent all underlined. Take it or leave it. Tricks are tricks, right? You either use them or you don't. As I said, it's not a trick I know, but it's probably a trick that was in Jean's video last year, and I was like, oh, that's kind of cool. Maybe the kids will like it. Okay, you ready for example 5?
Yes.
Example 5 is decomposing fractions with single term denominators using the constant multiple rule to rewrite. So constant multiple rule just being in terms of taking two derivatives. I don't know, I feel like those directions are fancier. Basically, we're just going to take some derivatives. Okay? Now, I guess what... Okay, here's what I want to say. Sorry, my brain is processing. There's rules we don't know yet. Okay? So, in order to do the quotient rule, on like that, this first one right there. We can't do the quotient rule on that because we don't know enough information. Okay, or at least not easy enough. Well, I guess we could do quotient rule. Sorry, I'm arguing with myself inside my brain. It's kind of coming out as I'm processing how I want to go about this. So, I guess, the idea here is what we're supposed to be looking at is, okay, how can I rewrite this when I just have that denominator? Another way to say 1 over the square root of x minus 4. I was thinking x minus 4 to a power. X minus 4 to what power? Negative 1/2, yes? Now, I guess technically we can do that because the insides is just x minus 4 and that derivative would still be 1. Okay, so I guess the point is that even though we know the quotient rule, do we still always have to use the quotient rule? Is that always going to be the easiest thing? And is it always going to be the easiest thing? Is a definite no. Okay, there are times you want to take an easier route. Now, differentiate. So differentiate means take the derivative. Okay. Derivative.
0.
1 to the negative, whatever that is.
Think in terms of the power rule. Negative 1/2 goes out front. And then what do I do to the power? Subtract 1. Negative 1/2 minus 1 is going to be negative 3/2. Is negative 1/2 minus 2/2?
Yeah. So we're not taking.
Would we get the same answer if we took the derivative of the original function? Because that's what I was trying
Like and use quotient rule?
to do. Yes.
Yes. but it's going to end up a lot more confusing.
The -4 inside of the parentheses kind of throws me off.
Well,
we don't take the derivative of it?
Well, if we're talking about that, the derivative inside, what's the derivative of x minus 4?
0.
Derivative of minus 4 is 0. What's the derivative of x?
1.
1.
Oh.
So the derivative of that inside is 1. We'll talk about that later on. That will be an upcoming rule of what to do when my insides is something I need to take the derivative of also. We're not there yet. Okay?
So just derivative of the outside.
Just derivative. And that's why I'm kind of surprised she threw this one in here. The other two, we don't have this issue, so. Okay. If we clean this up a little bit, negative exponent, don't leave negative exponents, don't be in that habit. Negative exponents go where? Denominator. So what am I going to have here?
-1 over 2 times quantity x minus 4 raised to
You can go even further with that too. Figure out.
Even farther in terms of we could put it in a square root, right? And I'm not going to right here, but you could put it in a square root. But then then you have a power cubed, which means technically we can simplify it, and
We'll just leave it like that.
we're going to stop here.
That
Yeah.
form stop.
Yes.
Okay. Now,
Apparently I don't
I will say, so like Emma had talked about, I don't think she was the only one, she was just trying to use the quotient rule. Well, if we look at that quotient rule, derivative of the top is 0, times the denominator isn't going to matter, minus derivative of that denominator, so you still have to do the 1/2 x minus 4, except now it would be just subtracting the 1, and then you're still doing over the x minus 4 1/2 quantity squaring. Okay, that's why it's very doable. It would work out to be the same thing, but there's something to be said for if you can take it out of the fraction form and not use the quotient rule, life can be a little bit better. Okay.
Not a
Now,
whole lot, but definitely.
if we write this one out of the fraction form, what do you see?
I'm stuck on this one.
Yeah, but you have to multiply x
Yeah,
by x
x.
over x.
My denominator is just an x. So I can think of this as x goes with each piece in the numerator. Oh, wait a minute. How does that make? Okay. Sorry. My brain's not there on this section today. 6x to the 5 halves over x. Think about that. I'm going to side note it here because I'm sensing some struggles. What's that simplified to so it's not a fraction?
4 halves?
X over
2.
3 halves.
No.
I have no idea.
Yeah,
One.
subtract.
Oh.
6 divided by 1 is 6. X to the 5 halves divided by x to the first, which is 2 halves.
X to 3 halves.
Oh. I thought it was subtraction.
Are we there on that one?
Yeah.
I know.
I think it's good.
It's rough today. It's rough today. Now, with this other one, the minus e to the x over x. That's not something where its powers I can just subtract, is it? What do you know about x? It's x to the first. If we're trying to truly get this out of fraction form, what does that go up as? We take it out of the denominator, it's x to the negative 1. So this is x to the negative 1 e to the x. I'm not sure that made it a lot great, but these are just kind of ugly problems, to be honest. Okay?
Next.
When did we learn all the e to the x rules? Like,
Probably algebra, too. Actually, I don't know. I just remember.
Well, we introduced a lot with logs and e's and stuff in algebra too. We did them some in pre-calc, but it was more, it was in algebra too. We didn't, I mean, that's one of those things that we could have talked about in pre-calc. I only have so much time in the year, and it's one of those things that kind of got nixed, to be honest.
So
So,
I know I'm taking the time here. don't mean to.
No, you're okay.
I'm sorry. What are some of like the rules? Like this one, what was this one?
This one, there was no rule. This was just an x to the first. Like, I can't, like, these up here, it was, the base is the same. I can subtract the powers.
Okay.
This one, I don't have a like base. This is just how do you get the x out of the denominator. This is just a negative exponent. It goes up.
Oh.
It goes up top and becomes -1. Like, how do you move, like, normally it's how do you get rid of a negative exponent? You move it across the fraction bar to the denominator.
Okay.
This is going the opposite way. How do we get out of the denominator? We make it negative up top.
Alright.
Okay. Let's do some derivative work.
I have an answer. I don't know.
Okay, the first piece. Derivative of 6x to the 3 halves.
9x
9x to the what?
1/2.
I think so. That's what my brain was saying.
That's what I was thinking.
1/2? Yep. 1/2.
I can agree. 3 halves times 6. My brain said 18 halves, which is 9. And then 3 halves minus 1. So 3 halves minus 2 halves is 1/2. We're at least there on that part, right? I'm struggling today. I'm sorry, folks. Now, be careful here because we are subtracting this next term, yes? What are we going to have to do? We're going to have to do the product rule. So,
I can't remember how to do
okay, so product rule goes back to yesterday, but that's part of tonight's homework, right? As we do this, guys, I'm going to put, and I don't know if I'm leaving enough space here or not, this product rule in parentheses. And the reason I'm doing that is because I'm subtracting whatever this derivative is. So I'm going to subtract, because that's what the problem was, the derivative here. Now, derivative of x to negative first times e to the x. Product rule. Derivative of one of them, keep the other. Plus, so I normally say derivative of the first, keep the second. Plus, derivative of the second, keep the first. So derivative of, we're looking at that right there, right? Derivative of x to the negative first. Negative x to the negative second times
E to the x.
e to the x. It's a product rule, so plus. Now, derivative of e to the x
E to the x.
times
X to the negative first.
x to the negative first. Told you, it's not pretty.
I don't know.
Okay. Now, I say, how much did I clean this up? Okay. 9x and 1/2, I pretty much just left. I might have made a square root later on. Okay, first term. Minus negative is going to say plus. If we're not leaving negative exponents in our answer, what do you know about x to the negative second times e to the x?
It's 1 over x.
Whoa.
Second.
E to the x over
X.
x to the second.
I was going to say e to the x over x to the second, because to get rid of the negative exponent, move it to the denominator. E to the x stays up top.
Minus.
What'd you say? Except that this is originally being subtraction, so I'm going to say minus e to the x over x.
Jesus.
I'm kind of out of room here, so I'm going to stop there. The only other thing I have done on my answer is I have it rewritten one more time and have 9 square root of x. Do you have to put the 9 square root of x? You don't. That's the only other thing I did on mine. I have it written 2 different ways, I guess. So, okay.
No, thank you.
What do we know about square root of x here?
It's
X 1/2.
X?
Negative 1/2.
Well, I'm just going to think of it as x to 1/2. It's in the denominator.
Okay.
Because,
And then do you have to split it up and put it with each of those pieces?
mhm.
Oh, goodness.
Okay, we're going to put it, because it's still going to be better than trying to clean up quotient rule in the end. Trust me. Okay, quotient rule gets ugly real quick. So, you're taking this to each of these 3 pieces, right? 6x to the 4th divided by x to the 1/2.
6 7 halves. 6x is 7.
6x is 7 halves? Because 4 is 8 halves. 8 halves minus 1 half is 7 halves. Fair enough? Plus
X to the 5.
3 is 6 halves. 6 halves minus 1 half is 5 halves. Minus
2x to the
2 divided by 1 is going to say 2. X to the first, so x to the 2 halves. Divided by x to the 1 half. 2 halves minus 1 half is 1 half. Are you there? Okay, let's derivative.
Just no multiplication.
Let's differentiate. Yeah, no product rule this time. Derivative of 6x to the 7 halves.
Don't shout out loud yet. I'm trying to think of it.
Okay, no one say anything out loud. I'll write it down.
6 times 6. I'm thinking, like, what are you doing? Just give
Now I can't even think. Oh my goodness. I don't know. Let's check and see if I'm right first.
take the first one.
On that first one, I did 21 times 5 halves.
Yeah. Yes.
Or excuse me. No, I did 21 times. I'm looking at the wrong thing. I did 6 times 7 halves. So I got 6 times 7 is 42. 42 divided by 2 is 21.
Mm-hmm. Yeah,
So-
I just had
I
the.
did the 6 times 2 is 6 divided by 2 is 3.
3. And that works too.
My issue was I couldn't remember what. 6 times 7.
6 times 8 is 48. Minus 6 from there is 48.
Yes, I'm aware.
I was going to. It's going with 6 times 6.
struggled with that for a second.
Okay. I have 21x to 5 halves plus 5 halves x to 3 halves minus 1 over x to 1 half. What do I need to clarify?
I'm good now.
Does your answer match my answer eventually once we clear up all
It's about to.
mistakes?
Oh, yeah. Yeah.
Oh yeah.
My master is,
Some of it is we have to get all of our careless mistakes out of the way, right?
They're never gonna be spoken.
Okay. They were all power rule.
But you're not gonna square.
5 halves out front. So 5 halves times x to 3 halves. 1 half times 2 is 1. Subtract 1, you're at negative 1 half. Notice I did not leave a negative exponent there. You could have this as, is this what you were just asking, Kylie?
Yeah. Doesn't
1
matter.
over square root of it. I know that they're equivalent. And Lordy, if you don't know that they're equivalent, I don't know what you're doing. Because I've gone over it about a bazillion times, haven't I? So.
Why are you talking?
My goodness.
Okay. Yesterday, there was kind of some freak out over the fact that we could do like the 10th derivative if we wanted to. Okay. So, speaking of higher order derivatives, I don't think we ever do the 10th derivative, but you could.
that'd be fun.
It just means taking the derivative 10 times in a row. That's all it means. Okay.
Just do it.
Now, oh, we do some big ones? Oh, because we have some patterns.
867.
Yeah, well.
Okay.
Okay, so we have some big ones. Sorry. Okay, let's get there. There's a reason. Realize, are we going to take 867 derivatives?
Yes.
I don't know. You might make us.
Not by the long way.
Come
The
on.
door is right there.
Okay.
I'll be gone.
Now, so, did you realize it's possible to take the derivative of a derivative? We'll need this ability in the study of particle motion and objects in motion, especially related to physics in the near future. There is a decent amount of physics in this course. Now, so, your base function is the position function, okay? That is your base function. S of t is what it's designated as right here. Sometimes you might see it as x of t. Trying to think what else, okay? Velocity, okay? Velocity, often known as v of t, is also the first derivative of the position function. And then we have acceleration, often known as a of t. Well, acceleration, it is the second derivative of position. So it's s prime of t. Or, since velocity is in the middle, it's the first derivative of velocity. Okay, so it's position. Then you take one derivative, you get the velocity. You take two derivatives, you get the acceleration. Okay?
I feel like the calc kids had an unfair advantage last year.
Well, sometimes it just gave them the advantage in here, in all honesty. I mean, and that is one where the physics, because my whole class was in physics last year, it gave them the advantage towards the calculus more than anything, really. I mean, yes, there were times it worked the other way,
Yeah.
but there were times that they would bring their physics knowledge into here, and it was really helpful. Okay?
I agree with Maria.
So, I mean, this is a year where I've had two people that have had physics, and the rest of you haven't. So it's always interesting to see the differences here. Okay, now, so this is just some definitions. We already talked about, if you want to relate it to the other page, that, I don't want to say, why did I write it that way? That does not make sense. Okay, but notation. First, second, third, fourth derivative. We usually use primes, yes?
Yep.
So y prime, f prime of x. You need to be familiar with dy dx. We haven't seen it a lot yet, but we will. Or you saw me writing d over d theta earlier to indicate the derivative of something, so d over dx. Okay, those are all first derivative notations. Second derivative. Easiest is just go to do double prime. So y double prime, f double prime. Now, over here, it's d squared y over dx squared, or d squared over dx squared. That's second derivative notation. Third derivative, triple prime or changing to threes. Once you get past so many primes, you can't keep them straight. Okay? How many prime marks do we want to count? And so you will see them use they almost look like exponents, right?
Yeah.
Okay, little exponents. Notice it's in parentheses, but once you get past, they're showing past the third, you're going to use numbers. Thus, we're seeing not 867 prime marks on that one upcoming example. We're seeing a number, right?
Oh.
Okay,
Imagine counting that. That'd be cool. I
so
think that my free response would be, I'll just do that.
is this my last page of notes?
Yes.
Okay, so I have 5 examples. Oh, lordy.
Well, we can do it.
Okay,
5 minutes.
okay, we've got to get these basics here. We're being asked to find the second derivative. Logic. How do you find the second derivative? You find the first derivative, and then you take the derivative of the first derivative.
And then you do.
Okay?
Oh.
That's finding higher order derivatives when you're just asked to find like first, second, third. You're just finding derivative of the derivative.
Multiplying fractions is the issue to start with. That's the only thing.
Okay. So, I'm going to start with f prime of x. F prime of x. 3 times 3 halves, subtract 1. 5 times 2, subtract 1. I have my first derivative
Goodness, you did that really fast.
You're really.
I know. Are we okay here?
Yeah.
9 halves x squared plus 10x minus 6. Because the derivative of 6x is 6, the derivative of 1 is 0. Now, second derivative then. Now you're just taking the derivative of what you just did. So 2 times 9 halves,
9.
9x to the first. Derivative of 10x,
Yes.
10. Derivative of minus 6, 0. There's your second derivative.
Good job.
Okay?
Ciao.
Now, jumping down. Well, where am I at? Okay, we can make this happen. Fifth derivative. There's not fractions here. You'll survive. So, first derivative. We there? Negative 12x cubed plus 21x squared minus 10.
Yeah.
That's first derivative. Second derivative.
Oh my goodness. Oh shoot.
Oh.
Keep getting harder.
Second derivative, negative 36x squared plus 42x. Third derivative,
Just negative 72x.
should be negative 72x, still plus 42.
Okay.
Oh, I did that.
Yep.
Way wrong.
Fourth derivative, and fifth derivative.
0.
Because fourth derivative is just a number, negative 72. Fifth derivative is then 0.
Oh wait, hang on. Wrong number I picked.
Oh, I keep doing just this. Oh, shoot.
Okay,
Oh, we're starting this already?
we're not doing 32 derivatives. Think pattern.
You just know that it's gonna be.
Okay, the original function is sine. What's the first derivative? Derivative of sine is cosine. Second derivative, what's the derivative of cosine? Negative sine. Third derivative, derivative of negative sine. So the derivative of sine is cosine. Derivative of a negative stays a negative then. Fourth derivative. Derivative of cosine is negative sine, so it's a negative of a negative sign, which is positive sign. Folks, what's going to happen here?
It's going to keep alternating.
I just got back to my original one, yes? Every how many derivatives? 4. We're going to repeat. So you're thinking multiples of 4 here. So right here, this is 1, 2, 3, 4, right? 5, 6, 7, 8, 9, 10, 11, 12. Are you seeing where this is going, right? Where's 32 going to land?
Oh, no.
32 is a multiple of 4, yes? Are you seeing where I'm going with this?
So it'll just be sin x.
So yes, the answer is sine x. The 32nd derivative, so d32y over dx32 is equal to sine x. And that's because we are smart cookies and we know that 8 times 4 is 32, right? It's a multiple of 4, and this repeats every 4. Now, of course, this one would be cosine. Can we guess we're going to have a pattern of 4 again? It's just going to be slightly different. So if y is cosine, y prime is negative sine. Derivative of cosine is negative sine. Second derivative, derivative of negative sine, negative cosine. Derivative of sine is cosine, keeping the negative. Third derivative, derivative of cosine is negative sine. It's a negative of negative sine, so sine. Fourth derivative, derivative of sine is cosine. Again, multiples of 4, yes?
Yes.
867
It's going to be really bad.
divided by 4. I'm doing long division by hand. Oh my lordy. 4 goes into 8 twice. 2 times 4 is 8. Bring down my 6. 4 goes into 6 once. 6 minus 4 is 2. Bring down my 7. 4 goes into 27. 6 times. 4
Oh my
times
God,
6
I had
is
no
24. Remainder
3.
of 3. Remainder of 3 says that my answer is
Sine X.
sine x. Which is why I did the long division by hand and not by calculator, because I wouldn't have my remainder. Now,
Yeah.
can you make it happen on the calculator?
Not really.
You
Kinda.
can. Okay, so y 867 of x is equal to cosine x here.
It's Sine X.
So no, I'm not doing 32 or 867
So it's,
derivatives.
wait, is it sin x or
Sine
cosine
X.
x?
Sine x.
It's fine, you got that.
I did. Sorry. Okay. I got all but one done. That's not horrible.
It's okay, it's the physics problem, we don't need to do it.
Yeah,
I don't like
exactly.
physics.
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 Anna and Sophie might be able to figure out the physics. The rest of y'all
Don't plan on it.
would probably have preferred that I do it. So
I'm gonna try.
we'll figure it out tomorrow if we have to, right?
So good.